4 times 7, which would be 28. Again, reduce fractions when possible. If we have 30 and 28, we can divide each of these by 2. So 30 divided by 2 would be 15. With a negative, we'll have negative 15. Divided by 28 divided by 2 would be 14. So our final answer, negative 15 over 14. And last question for the section. In parentheses, we'll have a mixed number, negative 3 and 1/3. Close parentheses, and in a second parentheses, a second mixed number, negative 2 and 3/4. Just like adding or subtracting fractions, when we have mixed numbers, we can change these into improper fractions. Improper fractions, again, we'll take the number in front, multiply by the denominator, and then add the numerator. So negative 3 times 3, we'll have 9, plus 1 more would be 10. And since we have a negative, we'll have negative 10 over 3. The second parentheses, multiplying 2 times 4 will give us 8, plus 3 more will be 11. 11 over 4, and again bring the negative sign down, so we'll have negative 11 over 4. When we have two fractions inside parentheses, we're still multiplying. Negative times a negative will give us a positive answer. Multiplying straight across, 10 times 11 will be 110. Divided by 3 times 4 will be 12. Again, reducing fractions when possible. Since both of these are even numbers, we can divide by 2. 110 divided by 2 would be 55, and 12 divided by 2 would be 6. So our final answer, 55 over 6. Title of the last section today is Review, Dividing Fractions. In this section, we'll divide two fractions together. One step or definition for the section is multiply by the reciprocal. In this section, when we divide fractions, we'll multiply by the reciprocal. The reciprocal, if you remember, is flipping a fraction upside down. First question and first two fractions, 2 over 7 divided by 3 over 5. When dividing fractions, the first fraction we'll rewrite as the same, 2 over 7. And using the definition, we'll multiply by the reciprocal. Instead of dividing, we can change this to a multiplication symbol. And we'll take the reciprocal of the second fraction. Instead of 3 over 5, we'll flip it upside down to have 5 over 3. Instead of dividing by 3 over 5, we can multiply by 5 over 3. And multiplying, we can multiply it straight across. 2 times 5 would be 10, and 7 times 3 would be 21. So our final answer, 10 over 21. Second question, 8 over 7 divided by, in parentheses, negative 4 over 7. Again, anytime we're dividing by a fraction, the first fraction we can leave the same. And instead of dividing, we can change to multiplication. The reciprocal of the second fraction would be 7 over 4. And if it's negative, we'll leave it as a negative fraction. Multiplying straight across again. 8 times a negative 7 would be negative 56. And 7 times 4 would be 28. Always check and see if you can reduce fractions. Negative 56 over 28 can be reduced. You could divide each of these by 2, or 28 actually divides into 56 evenly. Divides in twice, which would be negative 2. If you did reduce by 2, you could keep reducing until you get to negative 2. But 56 divided by 28 would be 2, so the final answer would be negative 2. Next question. We'll have a mixed number, 5 and 1/8, divided by 2 and 1/2. Mixed numbers again, from previous sections, we can change into one fraction or an improper fraction. Again, multiplying 5 times 8, which would be 40, plus one more would be 41 over 8. And again, instead of dividing, we can multiply. If we change 2 and 1/2 into an improper fraction, 2 times 2 would be 4, plus one more would be 5 over 2. But since we're multiplying, we'll do the reciprocal, which would be 2 over 5. Again, multiplying straight across, 41 times 2 would be 82. And 8 times 5 would be 40. Again, check to see if you can reduce fractions. Anytime you have two even numbers, we can always divide by 2. 82 divided by 2 would be 41, and 40 divided by 2 would be 20. So our final answer, 41 over 20. And last question for the section. Have a fraction 6 over 5 and a fraction line underneath, and a second fraction 4 over 3. This question, we have a fraction divided by a fraction, so we're still dividing two fractions. If we take the first fraction and rewrite that the same, 6 over 5, and instead of dividing by 4 over 3, we can change the dividing to multiplying, and the reciprocal of 4 over 3 would be 3 over 4. Multiplying straight across, 6 times 3 would be 18, and 5 times 4 would be 20. Reducing fractions again, we can divide each by 2. 18 divided by 2 would be 9, and 20 divided by 2 would be 10. So our final answer would be 9 over 10. The first title notes today is titled Review, Factoring. First question is 2x plus 10. One way to factor is to take out the greatest common factor, or the number that divides both of the terms. The number that goes into 2 and 10 would be 2. And then you put parentheses after and divide each of these by 2. The 2's divide out, you're left with x. And 10 divided by 2 would be 5. Next factoring question is 6y squared plus 8y. Again, we'll take out the greatest common factor, or the biggest number that divides both of the coefficients. 6 and 8. 2 again goes into both of those. This time they both have the same variable, the same letter y, so we can take out 2y. And again, we'll divide each of these terms by 2y. 6 divided by 2 would be 3. Y squared, we're dividing or taking out 1y, so we'll be left with 3y. Plus sign comes over. 8 divided by 2 would be 4. And the y divides out or cancels out. So you're left with 2y and 3y plus 4. Last question for review is x squared plus 5x plus 6. When we have a trinomial with a variable squared, the same variable in a number, this one we can factor by drawing the x or the diamond. Last number 6 goes on top of the x. The middle number 5 goes on bottom of the x. And we need two numbers that multiply to get the top number and add to get the bottom number. In this case, two numbers that multiply to get 6, and those same two numbers add to get 5. In this case, the answer would be 3 and 2. Your final answer in parentheses with x would be x plus 3 and x plus 2. The last section of notes today is titled Simplify, Rational, Expressions. The one definition or step for this question is to factor and reduce. The first question for this section is 6a plus 9 divided by 12. The definition of a rational expression is a fraction that contains a variable or a letter. To simplify, we'll first factor. We'll factor the numerator when possible and factor the denominator when possible. For example, the numerator, if we have 6 and 9, we can factor a 3 out of each of those numbers. Dividing by 3, we're left with 2a, and 9 divided by 3 would be 3. 12 is just a number or integer, which would stay the same. To reduce, if we have a coefficient or numbers that are left alone without variables, we can reduce those coefficients. For example, 3 and 12, we can divide each of those by 3. For the numerator, 3 divided by 3 would be 1, or it cancels out, and we're left with 2a plus 3. For the denominator, we have 12 divided by 3, which would be 4. And your final answer, 2a plus 3 over 4. The 2 and 4 do not reduce. If you have a plus sign for the expression, when dividing by 2, each number would have to be divided by 2. So your final answer would be 2a plus 3 over 4. Second question is 2m minus 5 divided by 6m minus 15. Again, for rational expressions, factor out the numerator separately and then factor out the denominator separately. In this question we have 2 and 5. There's no number besides 1 that goes into 2 and 5, so it cannot be factored simplified, so it's just 2m minus 5. For the denominator, 6 and 15, the biggest number that goes into 6 and 15 would be 3. And again, dividing each of these by 3, we're left with 2m, and 15 divided by 3 would be 5. In this problem we have the same term, 2m minus 5, and the same term on the bottom, 2m plus 2m minus 5. Both exactly the same, so what we can do is divide those or cancel those out. For the final answer, we have a 3, which is on the denominator or bottom of the fraction. There's no number left on top, but if there's no number left on top, it's kind of like an imaginary 1. So your final answer would be 1 over 3. And the last question for the section. 4x to the third divided by 28, x to the fourth. In this question, there's just one term in the numerator and one term in the denominator. There's no term separated by a plus or minus sign. So in that case, we can't factor, but we can reduce right from the beginning. In this case, we have 4 and 28. Each of those numbers we can divide by 4. 4 divided by 4, we can put 1 on top of the fraction, and 28 divided by 4 would be 7 on the bottom of the fraction. If you remember exponents, we'll be subtracting when we divide. X to the third minus divided by x to the fourth, subtract the exponents. 3 minus 4 would be negative 1. And also, if you remember from exponents, when you have a negative exponent, we can move that term to the bottom of the fraction and make that a positive x to the 1. The 7 would stay the same. The 1 would come over. And your final answer, 1 over 7x. The first section notes today is titled Simplify. Rational expressions. The first problem today is w squared plus w divided by w squared minus 49. Same steps as we did in the previous section. We want to factor the numerator first and then factor the denominator. For the numerator, each term has a w, so we can factor a w out. W squared divided by 1w would still be w. And w divided by w would cancel, but w divided by w would be 1. So the numerator, we're left with w and w plus 1. For the denominator, w squared minus 49 is a special factoring. This one is the difference of squares, where you can take the square root of each term. The square root of w would be w, and the square root of 49 would be 7. So we'll have w plus 7 and w minus 7. When you take the square root, one would be positive and one would be negative. To simplify, you want to check and see if any of the factors are the same on the numerator and denominator. In this case, they're all different. To cancel out a w, it has to be w just by itself. To cancel out w plus 7, you'd have to have w plus 7 in the numerator. In this case, nothing cancels, so your final answer in factored form would be w plus 1, divided by w plus 7, w minus 7. Next question for the section is a squared plus 2a plus 1 divided by 5a plus 5. In this question, we have a trinomial for the numerator, a squared plus 2a plus 1. In that case, we can draw the x to factor. The last number 1 goes on top of the x. The middle number 2 goes on bottom of the x. And we need two numbers that multiply to get 1, and the same numbers add to get 2. In this case, it would be 1 and 1. 1 times 1 would be 1. 1 plus 1 would be 2. So your factored form using these two numbers would be a plus 1 and a plus 1. For the denominator, 5a plus 5, 5 goes into each of these terms. And if we divide each one by 5, we're left with a plus 5 divided by 5 would be 1. In this case, after everything's factored, we have the same parentheses on top and bottom, a plus 1 and a plus 1. And again, like before, those divide out or cancel out. So your final answer are the factors that are left. In this case, a plus 1 divided by 5. And the last question for the section, m plus 4 divided by m squared plus 2m minus 8. For this question, m plus 4 is already factored and cannot be simplified anymore. For the denominator, again, anytime you have a trinomial, m squared plus 2m minus 8, you can factor by the diamond. Negative 8 goes on top, positive 2 goes on bottom, and we need two numbers that multiply to get negative 8. Same two numbers add to get 2. Those numbers would be 4 and negative 2. Again, when you have a negative on top, it means one number has to be negative. If it adds to get a positive 2, that means the bigger number is positive. So m squared plus 2m minus 8 factors to m plus 4 and m minus 2. Again, once the rational expression is factored, check to see if there's any common factors in the numerator and denominator. In this case, m plus 4 would cancel out or divide out. And our final answer, we have m minus 2, but keep in mind the m minus 2 is on the bottom of the fraction. And if everything cancels out in the numerator, you can put a 1 in the numerator. So your final answer would be 1 over m minus 2. The last section notes today is titled More, Complex, rational expressions. The first question is 5 minus 4n divided by 4n minus 5. In this case, neither the numerator or denominator can be factored, but if you look at the numerator and denominator, they are pretty similar. We have negative 4n and positive 4n, and we also have positive 5 and negative 5. What you can do in this case, when each number is off by negative, is for the numerator, we can factor out a negative 1. 5 divided by negative 1 would be negative 5, and negative 4 divided by negative 1 would be positive 4, and the n comes over. The denominator will leave the same, 4n minus 5. And now if you look at the two factors, both factors are actually the same. They're written backwards. We have positive 4n and minus 5. So since these are both the same, what we can do is cancel those or divide those, and our final answer would be negative 1. Last question for the section. 12 minus 4y divided by y squared minus 2y minus 3. Same steps as before. We'll factor the numerator and then we'll factor the denominator. The numerator, we have two numbers, 12 and 4. We can factor out a 4 from each of those. Dividing by 4, we're left with 3 minus, the y's cancel, or the 4's cancel, and you're left with 3 minus y. For the denominator, we have y squared minus 2y minus 3. Again, each time you have a trinomial with y squared or a variable squared, you can draw the diamond, where x, negative 3 goes on top, negative 2 goes on the bottom. And again, we need two numbers that multiply to get negative 3, and the same two numbers add to get negative 2. Those numbers would be negative 3 and positive 1. So y squared minus 2y minus 3 would factor to y minus 3 and y plus 1. Again, look at the numerator and denominator to see if any of the parentheses or factors are the same. Like in the previous problem, we have 3 minus y and y minus 3, which again are exactly the same, but they're off by a negative. So what we can do in that case is again factor out a negative from here. We can change this to negative 4. Dividing by negative 1 makes that a negative 3. Dividing by negative 1 makes that a positive y. So if we take a negative out from the parentheses, it'll switch to negative 3 plus y. The denominator we can leave the same. And again, negative 3 plus y is the same as y minus 3. The terms are just switched around, but we can cancel those out. And our final answer is what's left. Negative 4 in the numerator and y plus 1 in the denominator. Title of the first section today is Multiplying Rational Expressions. in this section we'll multiply